All right, page 243 in your textbooks. You did review 1 through 4, 6, and 8 through 11. Several of those problems, older review, even from the last test, and then a couple of them, some more recent stuff since the last test. We've been working on, well, we started with graphing, right? We started with graphing some equations. We graph a couple equations together to try to figure out where those graphs would intersect each other. So we'd get an XY answer that would be true for each of the equations. What do we call when we put those, what do we call a set of those two equations together, class? System of equations. And again, the goal is to see where would those two equations intersect. If the equations intersect, we get an answer, X and Y, right? And we would call the system, if the graphs intersect, class? Consistent. A system would be a consistent system. If the graphs don't intersect, we have an inconsistent system. What would lines have to be in order for them not to intersect, though, class? Parallel, which means they'd have to have the same slope. A little bit of review from the past. And we said, again, no solution to the inconsistent system because they never intersect. The reason we need the system, remember, is because by itself, just one equation has too many xy points that satisfy it. We would say that a single linear equation, or a single equation in general, class, is, since it has an infinite number of solutions that could satisfy it, indeterminate, right? Remember that word problem I said, the sum of two numbers is 9. There's a whole lot of answers you could give that would all be true, right? You can't determine what I'm trying to shoot for because there's too many answers. But we said it is possible that within a consistent system, your two lines, instead of intersecting like this, could actually coincide completely so that they would intersect how many times? Infinite, right? Well, that's still indeterminate, right? Too many solutions to work with. How do we describe the equations when the lines coincide? The graphs are coincident, but the equations themselves are said to be dependent equations when their graphs would coincide. And we did talk about, we had one problem, in fact, in the homework that involved dependent equations. And we're going to look at that in just a moment. All right, page 243, 1 through 4, 6, and 8 through 11. Not going for a piercing sword blade curve there. Otherwise good. And there we kind of go. All right, ish, plus or minus ish. All right, bueno. Yeah. With my microscope out. All right. All right, let's take a look. Number 1 said determine if the graph will have vertical translation, horizontal translation, vertical reflection, vertical stretch, or vertical compression. I don't usually use big words like that. All right, so number 1, the way I would describe it, what do we do to that equation? Kendall?
You go up 1 and to the right 4.
Up 1, forward 4. Good. Number 2, what do we do, Maddie?
You go to the left 5 and then you stretch it times 3.
Good. Go backward 5, stretch it 3. Number 3, what do we do there? Genesis? Okay, so what do you do? What'd you say?
I said horizontal translation.
On number 3? Michael?
Flip and compress 1/2.
Good, we're going to flip it and we're going to compress it half. Or if you use their terms, vertical reflection and vertical compression. Anyway, number 4, back to Genesis. What do we got here?
You're going to flip it and you're going to go to backwards 10.
Audrey.
You go down 10 and then you smush it 3/4.
Ooh, I like it, smush. Compress is still the word I use, but smush, I got it, right? I understand what you mean. There's smush it 3/4 or compress 3/4, and then also shift it down 10 or vertical translation. All right, so that's what we should have had there for 1 through 4. So make sure we don't forget those things. We'll see them again on the exam at the end of the quarter. Number 6 was the next one you're supposed to do. You're actually supposed to graph the equation y equals negative 4x squared positive 8x negative 1. In order to graph it, we want to get it into the standard parabolic form, or that graphing form. What do we need to do to get in that graphing form, Abby?
Pull out the negative 4 from the first 2 terms.
Good, just from the first 2 terms, factor it out so that your first term is just a plain old x squared. So whatever comes in front of it, pull it out. Well, when you pull the negative 4 out of the positive 8x, you get
Negative 2x.
We're going to leave a little bit of a space. We're going to recopy the negative 1. What goes in that space? Brandon? a positive 1, but it only looks like a positive 1. Really, Brandon, what's the value of this number? Negative 4. So to offset putting in negative 4 artificially, we have to add 4, right? It's wrong for me to steal $4 from you unless I immediately give them right back, in which case you're just very confused. But at least I haven't committed any crime, supposedly, right? So at this point then, we're going to keep the negative 4, but this perfect square trinomial gets factored back into, Kendall, a
X negative 1 squared.
binomial squared. And then, of course, we can combine the two constants at the end, Maddie.
3.
Positive 3. All right, so what am I doing to my base parabola here? There's going to be 4 changes I'm making to my parabola. Give me one of the changes we're going to make here, Michael.
Flip it.
Right here it shows we're going to flip it. All right, give me another change, Genesis.
You're gonna go up 3.
I'm going to go up 3. Another change, Audrey.
You go to the right 1.
Good, forward 1. And then the last change, Abby.
You stretch by 4.
And this is what makes this graph really, really annoying. Okay, so just showing a quick sketch here. Forward and up. All right, so forward 1, up 3. So right about here's where the vertex ought to be. We're going to flip it, so we're going to go down instead of up, and we're going to stretch 4. So instead of over 1, down 1, class, we're going to go over 1, down 4. Then we're going to go over 1, down 12, which is probably way off the chart. So we just have something kind of like that. And something like that. And there's kind of roughly what it should have looked like on your Cartesian plane. Of course, you would have had, by the way, x and y this time, right? They didn't use f of x, they used y, so we could use y. How many had something-ish like that for your graph? I saw a few of them somewhat similar. Good questions. All right, let's take a look now at the number 8, was also review material. Supposed to use the vertex formula for y equals x squared negative 16x positive 28. Though this wasn't too bad, because remember we said whatever is the coefficient has to be factored out. There ain't no coefficient. So all I have to do then is, what did I do to get the x, anyone? Negative half of the negative 16, which is, class, 8. So I know my x value is 8. To find the y value, I plug the 8 in. Here, square it. Multiply 8 by negative 16. Negative 128. And then add the 28, and that gives us negative 36. And that should have been our vertex, and that's all it asked for was the vertex. 8, negative 36. Somebody had that for number 8. All right, number 9. We finally get back to systems of equations. And they give us a 6x positive 2y equals 12. They also give us a negative 7x positive 4y equals 5. I don't think it actually helps us in this problem to do it, but what could I do to my top equation, anyone? Knock a 2 out of everything, get a 3x plus y equals 4. However, if I wanted to get rid of the y anyway, knocking out the 2 doesn't really get me any closer to matching up here, does it? So I'm not going to. Instead, we might multiply the top equation, Genesis, by a 2. Now, I'm going to hold off on the negative for just a moment, Genesis. I want to make sure I put the negative where the smaller numbers are. But at the very least, my top equation becomes
12 plus 4 equals 25.
Yeah, but seeing these numbers are all bigger than these ones, so I'm actually going to put the negative through here, and that bottom equation becomes
7x,
again, it's just my personal preference because I really hate negatives. Negatives just give me one more chance to screw up. I'll add the x's, class. 19x, obviously we see the y's canceled, and then here I'm going to combine to get 19. So we end up getting x is equal to 1. There's the abscissa. We need the ordinate. How do we go about getting the ordinate, Audrey?
You plug it in.
Where?
To the top equation.
Okay, plug it in the top equation. Make sure we plug it in for the x, by the way. Big mistake I see is students accidentally just, forgetful, plug it in for the wrong letter, so be careful. 6 times 1, class. Ditch that over as a negative 6 to get. And if 2y equals 6, then y equals, and how many had 1, 3 for your answer to number 9? Okay, several questions. All right, number 10. We've got a 9x positive 3y is equal to 0. and 3x negative 4y is equal to 30. Look at the top equation. What could I do to make things look a little bit simpler in that first equation, class? Could knock a 3 out of everything in the top, couldn't I? Say, can you knock a 3 out of a 0? Sure, what do you get? 0, right? Like if you're not getting paid anything, you're like, how many of you do your chores around the house and your parents pay you nothing for it, you get no allowance because they feed you, they clothe you, they provide housing and shelter? Okay, yeah, that was me too. And so, the one time I was like, Dad, I'm mowing these other lawns in the neighborhood and I'm getting like 40, 45 bucks for these lawns, and you've got one of the bigger lawns in the neighborhood. I'd just like to point this out, that if I were mowing your lawn, typically I'd get paid, about $40, $45. He's like, son, I give you a lot more than $45 worth of food, housing, and clothing. You sure you want to go this route? No, I don't. So anyway, but if, he's like, so I'm going to cut your pay in half for doing the lawn. Well, that don't bother me because I ain't getting nothing anyway. At least nothing financial, right? I'm getting all the other benefits. So I can absolutely knock a 3 out. Now, does it help me to knock a 3 out? Because if I knock a 3 out, then the 3x is matched. So let's go and take a 3 out of everything, class. Make this
3x plus 1 equals 1.
Yeah, and then at this point, I got to make the signs different here. And let's change the signs. I was thinking the top. Unfortunately, you're going to get stuck with a negative no matter what you do here, right? The 3x's cancel. The y's now, remember, negative 1, negative 4, negative 5y. And at least this number stays positive. 30 minus 0 is still 30. Divide away the negative 5. We end up getting y is equal to? Now, if you go back to this equation that you had right here, 3x plus y equals 0, and you were to plug in the negative 6 right here, you could move the negative 6 over as a positive to get equals 6. And if 3x equals 6, x equals 2. So our answer here should be written 2, negative 6. That's where those two lines would intersect if we'd taken time to graph. We're just too lazy. How many had 2, negative 6? For number 10. Okay, only a few of you that time. Questions on that? Could you do it without knocking the 3 out? Absolutely. You can multiply the bottom by a 3. You could multiply bottom by 3, top by 4 to knock out the y. The signs were already different. There are a lot of things you could have done there. Questions on number 10? Number 11. This was the weird one. So this is kind of what we looked at yesterday. We had this ugly looking 45x plus an 18y equals 27, and a less ugly 15x plus 6y equals 9. Now, as I look at this, I'm looking at that top equation like I could easily knock out a 9. These are all on the 9 times tables from when we were kids. So the top equation could become, class, and the bottom equation, I could knock out a 3. These are all my 3 times tables from when I was a kid. So these are the same equation, aren't they? These would coincide if I graphed them. We refer to these two equations, class, as being dependent. They're dependent equations. We see it when we reduce them down. So if I were to change the signs, I'd end up cancel, cancel, cancel. I'd end up getting what statement? When does 0 equal 0? Always. Now here's the deal. Technically, all real numbers could satisfy, suppose, for the one, but it's not going to satisfy necessarily for the other, right? Not all coordinates work, but all real numbers could be used for either x or y. So he said when you get to this point, when you get 0 equals 0, which essentially would be an indeterminate solution, we said we're going to introduce another letter. We call it, anyone remember? Well, we use t, right? We use t as either x or y, which we'll get to in just a moment. But we call it the blank. It starts with a p. Check your notes. Parameter. Make sure you got that term in your notes. The parameter. Parameter is simply an extra variable that's introduced to a problem to help to define or limit solutions. You don't have to write that definition down. Just be familiar with the term, the parameter. And I said we're going to use what letter for the parameter, class? T. And you're going to pick either the x to be t or the y to be t. It doesn't really matter. Genesis, what do you like to be the t? All right, so we're going to let the y be t. Now you're going to come to one of the simplified equations for your sanity's sake, and we're going to replace the letter y with the letter t. We already have y. We're choosing to represent it t, where t can be all real numbers. but based on what we would pick for t is going to determine the corresponding x. So I need to solve for x. To solve for x, 2 steps. Class, first, subtract the 2t, make it a negative 2t. Then, divide by 5. So what is x if y is t? 3 negative 2t all over 5. If, for some reason, you said, no problem with it, you said, I want the x to be t. Okay, not a problem at all. In that case, you would move over the 5t as a negative 5t and divide away the 2. So you could have had this. Both answers are acceptable. How many had one of those 2 answers here on number 11? Okay, a few of you questions on that. Again, it's just a way of representing every single point that could possibly fall in that line. Okay, and that's what we're using the parameter for, questions there. Let's practice with it again. Turn back to page 235. Page 235. Want to make sure we're good to go on this. Page 235. And number 10. I'm going to copy it down. Number 10 on page 235. There at the top of the page. The practice section. Page 235, the practice numero 10. Negative 5x, positive 20y equals negative 10, and 4x, negative 16y equals 10. And Michael, thoughts?
Take out a 5 out of the top and a 4 out of the bottom. Oh wait, take out a 5 out of the top.
Let's take a 5 out of the top, and what do I get when I pull a 5 out of everything in the top?
Negative x plus 4y equals 2.
Negative 2. All right, and then you started to say pull a 4 out of the bottom. You realized, 4 out of the 10 is going to be a real pain. But we could maybe take out 2 if we wanted to, or we could just leave it like it is and go from there. What do you want to do?
I'm going to take out a 2.
Take out the 2 to get?
2x negative 8y equals 5.
All right, so we've just given myself little numbers. I like little numbers. I pick on Kendall a lot, but let's be frank. Little is so much easier to work with. All right, Kendall, what do we need to do now?
You can multiply the top by 2.
Multiply the top equation by a 2, and that'll change my top equation now to say?
Negative 2x plus 8y equals negative 4.
We'll leave the bottom equation as is. 2x negative 8y is equal to 5. And now, when I add them together, I'll get the x's to cancel. Class, what do I get for my y's? They cancel as well. So all I've got is a 0 equals, and then on the other side, thoughts? Yeah, that's not true. Ever. Period. What's my answer? No solution. Apparently, and I just heard it from Abby a moment ago, class, this system is an inconsistent system. It would not work out if you graphed it. The lines would run parallel to each other. We get no solution. Why? Because we end up at a lie. So like politicians, you get a lie, you also get no solutions. All right, well, let's take a look at number 12. Number 12. We've got a negative 16x, positive 12y equals negative 80, and 4x, negative 3y equals 20. And let's see here. Maddie, what do you want to do here? Go to sleep? No, Maddie, that's not an option. Take out a 4 from the top, all right? What do we get when we take a 4 out of everything from the top? All right, for now, we'll leave the bottom equation as is. 4x, negative 3y is equal to 20. Then what should we do, Audrey? Yeah, add them up. I mean, the 4x and negative 4x are already going to cancel. Then from the y's class, they cancel, so I'm left with 0. And then here, the negative 20, positive 20. Also cancel to get 0. Thoughts on 0 equals 0? That's always true. 0 never equals 1. No solution. 0 always equals 0. Infinite solutions. Do you see the difference of when we have no solution versus when we have infinite solutions? And when you have infinite solutions, you will represent those infinite solutions algebraically using a third letter called the parameter. We're going to choose to use what letter, class? T. And you can plug the T in for either X or Y. Michael's choice. X. You go back to one of your simple equations. I'm going to go with this one here because it was original and not too bad. And we're going to replace the X with a T. T is how I represent the all real numbers that could be x. How do I represent the corresponding y values? Well, figure out what y is. How would I figure out what y is, Michael?
You get rid of the 14.
Okay.
And it turns into negative 14. You change the signs.
I like that.
You divide by 3.
And when I divide by 3, I'm going to go ahead and flip-flop here to put the negative after the positive. So I'm going to list the 4t, then my negative 20, all over 3. The other option I was considering was maybe a double switch to get the 20 as a negative and the 3y as a positive. And then divide by 3 would give us the same answer. But that's how we could represent our answers. The infinite number of them can be represented this way. All right, questions on the inconsistent systems and the consistent that are dependent equations where we have infinite answers. Questions on no answers versus infinite. Going once on questions. Going twice on questions. Write this system of equations down if you would, please. Y equals x plus 1. Y equals x plus 1. And for the next equation, y equals x squared minus 4x minus 5. Y equals x squared minus 4x minus 5. Here we have a little bit of a problem. It makes it awfully hard to line up like terms when one of them's got an x squared and the other one doesn't. Right? You can't really line up like terms here, can you? We could solve this by the graphing method easily enough, though. We know our top equation is what kind of equation class? X and y to the first power? Linear, right? This is slope-intercept form. This is going to be a straight line. We see here, now we're used to seeing f of x, but we've got the x squared, x to the first x gone. This is what kind of equation? Well, it's going to be a parabola, but it's a quadratic. It's going to be a parabola. How many times would a line and a parabola intersect? Probably twice, right? Got your parabola, got your line. Possibly never. The line could just whiff and miss completely, like a guy striking out in slow pitch softball. Or could be once if the line just is, here's a word for you, tangent to the parabola, right? Those who've been through geometry. That's a possibility as well. Well, I can't use the addition or elimination method to solve, but I could graph these. Go and get out some graph paper, maybe the graph paper you used for your homework. Set up a new Cartesian plane. And let's see, how would we graph a system of equations that involves a quadratic? Well, for starters, do the easy part first. Don't do the quadratic first. I mean, can't get much easier than slope-intercept form, right? So let's start with that easy part. So, for my first equation, which is where we're going to start by putting, class, your y-intercept at 1. Now, from there we're going to track the slope. What is the slope, class? 1 over 1, technically, right? So from here we're going to rise, run, 1, and just connect the dots. So not a bad equation at all to graph. And then we come to the quadratic. And yes, to graph the quadratic, we need to get it into our proper graphing form, don't we? So normally I'd say we're going to factor out something from the first two terms, but there's nothing to factor, is there? So if you can't factor, group it. That sound familiar? All right, so I can group the x squared minus 4x and then leave the negative 5 out in the cold. Like your younger sibling, when they're being annoying and your parents aren't around.
I did that to her once.
I bet. I don't doubt it. Hours, huh? How cold?
It was like 3 hours.
Oh, okay. At least you were in the south. All right, now, what goes in the gap here, class?
+4.
A +4, because we have to half and square. And you know, this time, it really is a +4, isn't it? It doesn't lie this time. It's a rarity for a politician. All right, so it's a plus 4. And, but since there's a plus 4, we have to offset that with a negative 4. And then we're going to take our PST factored into a binomial squared to get, and then combine like terms at the end, the two constants to get. All right, so we're going to shift our parabola class down 9 and forward 2. All right, so we're going to go forward 2, down 9. Lovely. And there's no stretch to it. And it doesn't flip down or anything. It's just over 1, up. 1. Over 1, up. 3. Over 1, up. 5. Over 1, up. 7. You can actually see the points happening right before your very eyes. You almost don't even need to graph it now, because you can see the 2 points of intersection. We've got a point right here, class, at 6, 7. And there's another point at negative 1, 0. We thought we would get 2 points of intersection, and we did. 6, 7, negative 1, 0. But do we really want to dig out the graph paper and figure out the proper parabolic form and set up the Cartesian plane and do all this over 1 up, 1 over 1 up, 3 over 1 up, 5 over 1 up, 7, and so forth? Or would we rather have a method like the addition elimination method where we can do it all without graph paper? But just not addition or elimination because, no like terms, right? Method number 3 for solving systems of equations. Method number 3 for solving systems of equations, to liberate us from the graphing, is the substitution method. Method number 3, substitution. Method number 3, I'm going to go and erase the graph. Substitution. If you would, make this note. Substitution always works. Graphing can be a real pain and doesn't work very well. The addition method doesn't always work. If there's no like terms, you can't use it, right? The substitution method always works. So if you had to learn just one method, this are it. I'm not saying it's always the easiest method to use, but this is the method that's always going to work for you. And frankly, I don't think it's that hard. Step number 1, get a letter by itself in one equation. Get a letter by itself in one equation. Now here we actually have a letter by itself in both equations, okay? We've got the y by itself in the top equation, we've got the y by itself in the bottom equation. If for some crazy reason you wanted to get x by itself, it'd be easy to do that as well. In the top equation, what would I get if I had x by itself in the top class? If x was by itself, y minus 1, right? The 1 would move over as a negative. I don't want to do that. I've already got a letter by itself. So step number 1 is done. Step number 2 is to substitute into the other equation. Substitute into the other equation. Here's what I mean by this. Per the top equation, class, what is y? It's x plus 1. That's what y is. That's what y equals. Well, right here, I see a y. You know what that y is? It's x plus 1. So I'm going to substitute, instead of a y right here, it's going to say x plus 1 equals x squared minus 4x minus 5. Do you see what we did with the substitution? Took what one thing was equal and put it there, and moved on with life. Step number 3. Solve for the remaining variable. Solve for the remaining variable. By substituting for y, y is gone. All that's left is x. So we're going to solve for x. Now, what kind of equation do we have here, class? It is a quadratic still, right? So when I solve for x, I'm going to solve it like I would solve any quadratic. Set it equal to 0. And I'm going to put the 0 over here. I'm going to move the x over as a negative x. I'm going to move the 1 over as a negative 1 to get class. And then I've set it equal to 0. Now I factor. How would I factor x squared negative 5x negative 6?
X negative 6, x plus 1.
X negative 6x positive 1. And then, of course, we set each factor equal to 0 to get 2 x's. What are the 2 x answers, class? Positive 6 and negative 1. Now, those are both x's. I have an x value or abscissa of 6. I have an x value or abscissa of negative 1. Those are not y values. Those are x values. Step number 4, plug these values, or in some cases this value, into the rearranged equation. Now in our case, in step 1, we didn't rearrange anything. It was already had a letter by, it already had a letter by itself. But oftentimes we'll have to rearrange an equation to get a letter by itself. We're going to go back to that first equation we started with, and we're going to plug in the x. X is 6. Well, if x is 6, class, what's y? 6 plus 1, 7. We're going to also plug in the negative 1. Y is negative 1 plus 1.
0.
Oh, the same 2 points I got when I graphed, right? But no graph. Easier. It's even easier when you're not dealing with quadratics, but linear equations. Write this linear system down, if you would, please. X plus y equals 8. 2x plus 3y equals 19. Now, yes, I know we could multiply the top by 2 and then put a negative through and do the addition method. We could, but we're practicing the substitution method. So we're not going to do that. Instead, class, we're going to get a letter by itself. Bottom equation, that'd be a pain. So I do it in the bottom equation. I'm going to do the top equation, wherever it's easiest. And it's kind of equally easy for x or y, so we're just going to let Abby choose.
Get x by itself.
So that means we're going to rearrange this to get x equals
8 minus y.
8 minus y. That's what x equals. That's what x is. So right here, class, I see an x. You know what that x is? 8 minus y. So I'm going to write where this x is? 8 minus y. I'm not going to change the 2. The 2's still here. But instead of a 2x, it's a 2, 8 minus y. This plus 3y is still here. This equal sign is still here. The 19 is still here. Nothing about the bottom equation changes except it used to say x. Now it says 8 minus y. That's all that changes. We substitute it into the other equation. So Genesis. X is that. X? That. Make sense? All right. Step number 3. Solve for the remaining variable. Nice thing is, this isn't quadratic. All I have to do to solve this equation, class, start by distributing to get. And a lot of times students will, as they plug the 8 minus y in, they'll distribute the 2 at the same time. I have no problem with that. I'm lazy too. Plus 3y equals 19. Then, of course, we'll combine like terms, class. And at the same time we combine, we'll kick out the 16 as a, to get y equals 3. That is my ordinate, 3. Finally, we're going to go back to the rearranged equation and plug in the 3. Here's my rearranged equation that Abby rearranged for us. Instead of a y, it's 3. That's what y is. X is 8 minus y, or 8 minus 3, class. And if I had graphed the system, that's what I would have gotten. If I'd solved by addition or elimination, that's what I would have gotten. Easy enough? Letter by itself, substitute it in, and solve. Write this one down. 3x plus a half y equals 8. 3x plus a half y equals 8. And 5x equals 6 positive y. 3x, or 5x, excuse me, equals 6 positive y. Now, as you were copying it, a thought should have gone through your head. I hate fractions. How many thought, I hate fractions, or I hate this when you wrote the fraction down? Only a couple of you have been well indoctrinated. The rest of you have far to go. What do we do in that top equation? Because I just hate fractions. Just multiply by 2 real quick. Let's just knock it out. Top equation becomes what, class? 6x plus y, that cancels away the fraction, equals 16. And the bottom equation, for now, still says 5x equals 6 plus y. Now notice, I don't have like terms lined up, do I? But I don't care. That's nowhere in this lineup. You don't need like terms lined up in substitution, which is good if you don't even have like terms to begin with, but it's also good if you don't feel like rearranging stuff. Now, would it be that hard to bring the y over as a negative and allow the y's to cancel and solve the addition method? No, I get it. This is just another option, right? It's like going down the candy aisle or going, the checkout aisle and all the candy's sitting there. How many of you, when you were little, mom said you get one thing from the checkout, the candy? How many of your parents always said no when you wanted to? My parents too. That's what I do to my kids. All right. So anyway, but it's like, oh, so many choices. You only get to pick one. Just pick whatever sounds good. Maybe one day substitution sounds good. Another day, like, man, that elimination method looks really good. I know. I'd rather have the candy bar than solve math problems. But anyway, we need to get a letter class by itself. I could get the y by itself here, or I could get the y by itself here. It's up to Brandon. Top equation, so we ditch the as it. There we go. So top equation is going to become y equals 16 minus 6x. There is nothing wrong with you doing it in the bottom. He decided to do it in the top. We're going to roll with what Brandon said. That means, class, that y is 16 negative 6x. So right here, class, where it says y, what am I going to put? 16 negative 6x. Going right there. So what does this lower equation read now? Genesis?
5x equals 6 plus 16 minus 6x.
Perfect. Where I'm going to combine the 16 and 6, class. And at the same time, I'm going to move the negative 6x over as a, to get, I'm going to solve it in our heads, class. What's x? X is 2. There's the abscissa. Now, what about the ordinate? Well, right here, the rearranged equation, put the 2, where the x was. What is 16 minus 6 times 2, class? 4. 2 4 is my answer. We're done. I don't know that it's easier than addition or elimination. I don't know that it's harder than addition or elimination. Just kind of whatever flavor you feel like at the moment. We'll write this one down. 5u minus 60 equals 9v. Yeah, this works with other letters too. It doesn't have to be x and y. And 8 positive 4v equals 4u. Now, at first glance, you're like, there's really not an easy letter to get by itself. Like here, this was already a plain old y, right? Or once we cleared the fraction, this was a plain old y. Or in the previous example, we had a plain old x. I don't have a plain old anything. But, thoughts, class? Knock a 4 out of the bottom equation, and what does it read? Good job, Brandon. The rest of you, do you see what he did there? Good job, Brandon. Favorite student right there. All right, 2 plus v equals u. And look what we got. We got a letter by itself. So I'm going to substitute. Right here where it says u, class, what am I going to write? 2 plus v. Let's see if we can distribute at the same time. It's going to be a 5 times the 2 plus v. In other words, class, 10 plus 5v minus 60 equals 9v. Questions on what we did there? If you're afraid you're going to screw that up and do 10 plus v, then don't do it, young person. Write 5 parentheses 2 plus v so you don't mess it up. If you feel like you can do it, more power to you. Let's combine the 10 and the negative 60. Negative 50. Let's ditch the 5v over as a negative 5v to get 4v. And, oh, this is unfortunate. What do we get for v? Yeah, negative 25 halves. Negative 50/4, but that can reduce to negative 25/2. And there's my v. Now, alphabetically, is v the first letter or the second letter? T, U, V, W, X, Y, Z, right? So v would be the second one. So we're going to put the v in the y slot, the negative 25/2. And now what do we do to get the u? Well, go right back here. Plug in the negative 25 halves. It would be helpful, though, here, if the 2, instead of a 2 or 2 over 1, were written as a fraction. Something over 2. Well, 2 is the same as 1 over 2, class. 4 halves, right? 4 halves is the same thing as 2. 4 halves plus a negative 25 halves. Negative 21 halves. And there we go. It's not a pretty answer, but yeah, whatever. Questions on the substitution method? Your turn. Page 235. At the bottom, do the review 7 and 8. Page 235, do the review 7 and 8. Once you use the substitution method as it says. I know it looks so easy by the addition method, but practice with the substitution method. So that in those days when you can't add or eliminate, you can always solve by substitution. Page 235, number 7 and 8 in the review. Michael's finished, Brandon's finished. Janice is finished or thinking? Okay. Most of you finished. If you are finished, check your work and your answers. Not finished, take just another moment, that's fine. If you're good to go, back to page 229, do 9 through 12 in the practice section. If you have questions on 7 or 8, though, please ask those now. Any questions at all on 7 or 8? Move this lectern out of the way so people can see. Any questions on 7 or 8?
I combined it with 5. Like I did on number 7.
On number 7?
Yeah.
Oh, you copied it wrong.
Yeah.
Oh, gotcha. Okay, yes, ma'am.
On number 8, somehow I got 4 equals 4.
4 equals 4?
Yeah, my x's cancel.
You brought, did you solve by substitution?
Mm-hmm.
All right, so what top or bottom? Which one did you read? You went bottom. So you went y equals 4 minus 3x, right?
Mm-hmm.
Okay. So right here in the top equation is where we should have plugged in the 4 minus 3x. If you plugged it in here, that's where you get 4 equals 4. So you got to make sure you take the one you didn't rearrange and plug in there. Does that make sense? Great question. I'm actually really glad you asked because Gavin or Brecken might have had the same question. All right, any other questions, 7 or 8? That was a great one there, Audrey. Good. All right, working on 9 through 12 now at the top of page 229. Again, practicing with the substitution method, even if you feel like, man, it'd be so much easier by the elimination method. Well, in time, I'll let you choose how you do it, I promise. But for now, I want you to practice the other method so we get good at it. Because there will be times you'll have to do it this way. Any of you from my Algebra 1 class in the past remember doing this now?
I was in your class.
Still not. Okay, all right.
I was in your class.
Okay, just curious. I was like, maybe this method would be like, oh yeah, I do remember doing this. Whatever.
It's Maddie's fault.
Maddie's fault? Gavin, if you remember it, Brecken, if you remember it, email me. Hey, yeah, I remember doing this. Make me feel better. Not gonna lie, number 10 really makes me want to use addition. I mean, it's right there.
Yes, I did review 9 through 12.
Well, do the practice 9 through 12 real quick then.
That's when I
I
started.
think we already did the review 9 through 12 like before the last test. But you know, hey, I'm not going to judge too harshly. Just a little harshly.
Great.
All right, take your time, pencils down, check your answers to 9, 10, 11, 12. Even if you didn't finish all of them, check the ones you did get done. How about all the ones you did correct? All the ones that you got done were correct. Okay, questions on any ones that we missed then? Any questions at all on ones we may have missed? Going once on questions. Going twice on questions. All right, one problem for extra credit tonight. You don't have to do it if you don't want to, but if you want to get some extra credit on your exam, page 229, practice number 13. Page 229, practice number 13. It's going to be what we lead off with tomorrow, so I want to give you a chance to work it for extra credit tonight if you want to do it, and we'll take a look at that tomorrow as we finish up or review over these different ways of solving systems of equations. All right, have a wonderful rest of the day, and you are dismissed.